This video is about graphing absolute value functions. We briefly talked about this when we were talking about parent functions the other day, but I want to go more specifically into absolute value functions. So let's start with this first one that's on the screen. What I'm going to do to graph this is start by looking at my k value, the stuff that's after the absolute value stuff. So I've got this -4. So I know my y value here is going to be -4. I see that inside of my absolute value bars, in the inside, there's no value. So I have no shift on the x-axis. So I'm just going to plot my point at -4 on the y-axis, right here. So the next part I have to worry about is the 3. So for an absolute value equation, the number that's in front of the bars effectively is the slope of each line, okay? So with a slope of 3, that's up 3 and right 1. So that's 1, 2, 3, 1. Just like this. And I like to make 2 points just to make, or 3 points to make sure that my line is nice and straight. Now with an absolute value, no matter what number you put in, positive or negative, you're going to get that positive value back out. And what that manifests as in a graph is a V shape. So if I've got it going this way, I've got the opposite on the other side. So I'm going to go 1, 2, 3 up and 1 left. 1, 2, 3 up and 1 left again. And just to make that V shape. Let me grab a ruler. My cat's laying on it. I'm sorry. And then we can go ahead and basically just connect the dots and make our line. Every absolute value graph that is not bound by domain or range is going to be this V shape. Let's look at a little more complicated one. We're going to go through the same process here. I'm going to notice that my graph is shifted up 2, so 1, 2. Now inside the bars, insiders lie. So that -4 means I'm really going to move forward to the right, okay? Which is, it's backwards. Just remember, insiders lie. So he says -4, he's lying. I'm going to go +4. 1, 2, 3, 4. So my vertex is right here at 2, 4. Okay, now I'm going to look at what's in front of my bars. And I've got a -3. So I'm going to make a slope of -3. 1, 2, 3 down. 1, 2, 3 down, 1 over. Down, 1 over. 1, 2, 3 down, 1 over. And you can see I've got the same V shape, so I know I did it right. Connect my dots. And that's all there is to it. Let's do one more kind of like that. Here I see that my graph is shifted up 1, insiders lie, so it's shifted to the right 1. So up 1, right 1. My vertex is here, 1, 1. My slope this time is going to be 2, so that's up 2 over 1. 2 over 1, and it's positive, so I'm going the right direction. I always like to double check. We're going to connect the dots. They're nice lines. Always make sure you put arrows on there because they're continuous. And there we go. Not too bad. The last thing that I want to do is finding the equation of the graph from one that's already plotted. So the first thing that I'm going to do is look at this and say, what is my vertex? And I'm going to write that off to the side, just like notes. So my vertex here is -3, +4. I'm also going to take a look at my slope here. It looks to me like I go down, so it's going to be negative. Down 1, 2, 3 over 1. So a slope of -3. Or -3 over 1, if that's more your style. So when you're doing these, it's really very simple. Y equals, the slope goes in front of the bars. I've got my x. Remember, insiders lie for our horizontal, so I'm not going to put -3. I'm going to put +3. And then my k value is how far it shifted up, which was 4 units. And that's really all there is to graphing absolute value and writing the equation from a graph of an absolute value function.